Thanks for joining this session entitled Hybrid Confidential Container Deployments here at SUSECon 2023. We would like to show you today how you can address your security needs with privacy-enhancing technologies like confidential computing by leveraging the SUSE SLE BCI container images within the HyperTech platform of IBM. My name is Nicholas Meading, and I am the product manager of this platform. With me today is Neil Bornstein, Senior Sales Engineer at SUSE. So with this, the floor is yours, Neil.
Thank you, Nicholas. So let me go over the agenda for this talk, first of all. The first section, we will talk about how we combine containers and confidential computing using the IBM HyperProtect platform. Second, we'll talk about using the SUSE Linux Enterprise base container images with the HyperProtect platform. And then finally, there'll be a short demo on how to build, publish, and deploy a SLE BCI-based application with the HyperProtect platform. So first, let's talk a little bit about containers and how they help you focus on the application. Everyone, I think, at this point is fairly aware of virtual machines and containers, but the idea is that with the traditional VM deployment, you have infrastructure, of course, you have a host operating system, and then a hypervisor, which then lets you run virtual machines, each of which contain a guest operating system and all the applications and libraries that you need to run your application. In the container model, we take out the guest operating system. So the container engine takes the place of the hypervisor, and then your applications run directly on libraries and binaries running within the container image. This makes containers more flexible. You have a smaller image size because all you have is the application and its dependencies. It makes it increasingly portable because you can run on any container engine, on any operating system and infrastructure. It requires less resources because you don't have that full operating system. You just have the application within each container. This also makes it faster to start and stop because you're not starting and stopping an entire operating system. Again, just the application. And it gives her a smaller attack surface because all you have in the container is the application itself, no operating system with all its vulnerabilities. Now, there's a project from the Confidential Computing Consortium that is working on protecting data in use. Everyone should at this point be familiar with the concepts of protecting data in transit and data at rest. But data in use means the data actually in memory in the processor while you're running an application. Without confidential computing, you have certainly operational insurance that you can run your applications, but there's no way to technically assure that your applications are secure. Sensitive data is at risk in cloud or hosted environments because you're using shared infrastructure and shared hypervisors. So that means there's potential exposure by the cloud service providers, employees, processes, and systems. And these are running in multi-tenant environments, which can be compromised by bad actors. This particularly affects regulated industries. Now, with confidential computing, you have a more technical assurance of security because it's built into the platform. Sensitive data is secure in these cloud or hosted environments, which helps you avoid data leaks and protect the workload data in memory and in the CPU. And then you also have exclusive control of the keys for data encryption while at rest and in flight. These things are stored in your workload's memory, so you can actually be ensured that they are encrypted in use. And then with privacy enhancing technology, the policy implementation and regulatory compliance are simplified. Now, how do we combine confidential computing with containers? And this is based on a project from the Confidential Containers Foundation. Looking at the previous chart, we had a secure hypervisor. Now we run a confidential container runtime inside that hypervisor. This is an open source community working group which enables the protection of workloads in containers. Nicholas, you want to tell us about the HyperProtect platform?
Sure, as you might know, IBM started to offer enterprise solutions leveraging privacy enhancing technologies like confidential computing already in 2017 with the secure service container. So the concept to have protection boundary and leverage the advantages of containers aligns perfectly with our vision and what we observe in the community and the industry resonating. Cloud native is the main trend to develop state of the art solutions, in my opinion. So, what is that HyperTech platform? It is an offering available on premise and in an IBM cloud. So, it builds with your hybrid cloud needs, and you can build once and deploy everywhere. It leverages secure execution for Linux, which is the confidential computing technology we offer for our LinuxONE and zSystems system. And this technology is key for our platform. With the privacy enhancing technology as base, it offers a technically assured container runtime into which the actual workload is deployed based on the open container images. We have introduced unique features into that underlying stack to simplify data sovereignty and protecting your IP, keys, and secret so you have full control. So, what are the use cases we see? For use cases, we see actually any containerized workload in mostly any environment or deployment type. For me, it is like the journey from HTTP based data in transit or data in flight encryption to HTTPS based being the standard everywhere today. We envision the same will happen regarding containerized workloads. Fast forward, and I see that confidential computing is basically the default for any of these deployments as HTTPS is for data in transfer and network traffic today. As always, you have areas which benefit more or have a greater need. I would like to highlight digital asset here. Financial institutions are fast and adopting digital currencies, tokenizations, and even central bank digital currencies become reality very soon. But with NFTs and Web3, which is a fast evolving and emerging market, we also see different areas where these aspects, which we are concluding under digital assets, have new solutions in place and others being published or being worked on as we speak. So we see a wide range of governmental authorities, banks of any size, and legacy or small startups having use cases around what we highlight and from a high level as digital asset. But it's also about collaboration and intellectual property. For more important from our perspective with the HyperTech platform, collaboration across entities is enabled. So you really have multiple parties which previously, because of regulations or individual interests, were prevented to join forces, can now work on a common goal and benefits without exposing individual data or unique selling points. This has multiple layers. And with the rise of AI, it becomes more and more relevant that you have many setups and solutions where you need this kind of protection with which confidential computing and the HyperTech platform offers. It may be the creation of fundamental models preventing the IP which went into these become exposed afterwards. It might be the ISV which offers some unique solutions based on these models, or companies in the same industry, assurance as an example, which needs common insights but may not expose the data of their clients as they are doing so. Governmental agencies collaborating and regulation authorities needs to get insight across boundaries of companies, and it must be ensured this is not exposing any IP information or secrets. And of course, private usage with their right to have data sovereignty and protection, which while they interact, for instance, with their healthcare insurance company or with their own health record, these are all aspects which we see where these technologies will benefit and our solutions can be applied for. So you may have your own use case or unique idea already in mind, but all this depends on a solid and secure foundation. And we at IBM HyperTech Services are convinced that technically assured solutions are the way to go. But you need a stack solid and efficient in your deployment of these workloads. And for that, One example is to leverage the SLE BCI-based container as a basis for your workload deployment. And as the containers are hardened already, you have a stack to build your unique use case and address your needs with this offer. So Neil, what do you think? What is possible already today?
Yeah, I think that's a fantastic intro to the SUSE Linux Enterprise base container images. These are images based on SUSE Linux Enterprise, so they inherit all of SLE's security and compliance posture from the underlying operating system. They're security hardened and FIPS enabled to make sure you are compliant where you need to be. And they provide a secure base for any containerized workload. These BCIs are purpose built for cloud native use cases. They can support being run on any Kubernetes distribution, including those that come with SUSE Linux Enterprise, such as Rancher, or on IBM's Kubernetes distributions, or any of our other competitors or friends. They can be leveraged in the hybrid cloud or on the edge. And again, they are integrated with SUSE Rancher already. They provide flexible software development. They can run, again, with any Linux operating system underneath. They're lightweight and easy to adopt. And you just get what you need so you can avoid multiple confusing configuration options. A little more detail about the base container images. They provide an open, flexible, and secure container image and related tools for immediate use. That means you can run your application development and deployment platform of choice without lock-in to any particular upstream vendor. They match the need for regulated markets because they are security hardened and certified based on the SUSE Linux Enterprise operating system. We have two sets of container images across multiple architectures, including the IBM Z and LinuxONE platform. There are pure SUSE Linux Enterprise-based containers with a minimal set of packages for rolling your own applications and workloads. And then there are container images that can contain a base environment for a variety of programming languages that can include Python, Node, Ruby, and so forth. Some of these are only available on the Intel x86 architecture, but there are a wide variety of other runtimes available across different architectures. Now, the important thing here is that they support any Linux host and Kubernetes distribution. You can build and deploy based on the SLE-based container images in any OCI-compatible environment. And the best part is that they are freely available for download at registry.suse.com, and that includes regular updates, so that you can be assured that when you rebuild your container images, they contain all the latest patches to give you a secure environment. Now, what does this look like in the hybrid confidential computing deployment? So on this chart, you can see two starting points. At the top, you see the IBM cloud. At the bottom, you see the on-premise or hosted data center environment. The only difference is where you're deploying. Everything else works exactly the same. You provide an image, in this case, on the top with the IBM cloud. There are images provided in the VPC image catalog. On the bottom, you can see you can provide an HBCR image through the IBM Passport Advantage. But that's just the beginning point. Once you have the image, then you can continue the same in either model. We define a contract that enables the transfer of secret individual deployment and to enable zero knowledge proofs. And we'll talk more about this in the demo. Once that contract is defined, you simply deploy your image in the hybrid, in the HyperProtect computing platform, connect to a logging service to provide observability into your workload, and then run the container within that environment. Now, if this sounds a little bit complicated, be aware that there is a document, a technical reference document on how to get started with confidential computing with the SLE BCI on the HyperProtect platform, and this will be available for your use. Now let's take a look at the demo. In this demo, I'm going to show you how to run a payment processing website in the IBM HyperProtect virtual server running on the IBM cloud. The workload itself is defined using Docker Compose. You can see the Docker Compose file right here. It has a couple of things defined. The first thing is where to get the container image from. This is on GitHub. I'll show you more details about that in a minute. And then what ports to open, 8080 and 8443. Now this Docker Compose file is going to be base64 encoded and then embedded into a contract. The contract shows me, first of all, how logging is going to work. I'm going to use the IBM Cloud's logging service, and here's information about the endpoint and an ingestion key. And then here's the workload itself, including that base64 encoded Docker Compose YAML file, and then my username and password to pull the image from the GitHub container registry. So let's look at what that looks like when I actually launch it in the IBM Cloud. I'll click on Create to create a new virtual server instance. And I want that to be running on an IBM LinuxONE or System Z mainframe. I do want that to run in the HyperProtect environment, so I want to click on Confidential Computing. I'll give it a name. And then the only thing I need to still do is add user data, which will tell the environment how to run my workload according to that contract. So I'll click on Create Virtual Server. Now, I need to have a floating IP assigned to that virtual server. So I'll go to floating IPs. I've got one already set up. All I need to do is bind it to that instance and click Bind. Now I'll go back to that virtual server instance and we'll attach to the serial console so we can see things moving along. Now this will take a minute, so as we're moving along, I just want to flip over and show the Docker file that defines this workload. This uses the SLE base container image for Node.js, and you can see right here in the Docker file, it's very simple. We pull that base container image here, we add a couple of labels, and we copy in the actual application and define the command to run the application. So let's see where we are. I'm going to go back to my virtual server. You can see it's continuing to set up. This won't take very much longer. You can see the logging has been configured. So that's my cue to flip over and look at the logging to view more details as it happens. In a moment, we will see the container being pulled from the registry. And there it goes. You can see up here, it's been pulled and extracted to the local system. And then once this is all done, we'll see that the workload has started. It looks like it should be done, so I'm going to flip over to the website. And there it is. Now I can click on Pay Now, enter some PII. I can enter a credit card number. I can enter a payment amount and click on Pay Now. And that information, of course, is transmitted over SSL to the website. It's stored, encrypted on the disk, and any information stored in memory and in the processor is also encrypted.
Thanks, Neil, for this great presentation and demo and the collaboration. With this, we conclude the session, and we are looking forward to get in touch as you look into your use case or customer need and like to leverage the SLE BCI containers on the HyperProtect platform to bring hybrid confidential computing deployment to reality and production usage. Thank you.